Here we are at another lateral valve control box, and we noticed that there is a sound coming from this valve even though it's off. The clock is not operating this station, but when we open this box we hear the water flowing through the valve. That hissing sound is the water flowing through the valve. We can manually activate the valve with this lever, flipping that little pilot plunger up and opening the valve, and we see the irrigation system come on in the garden, fully on. Then when we close the valve, we hear it hissing that it hasn't closed fully, so it's leaking. One of the things I noticed, you might have heard when we just closed that valve, the sound of it slamming closed. It made a loud clunk as that stopper closed. I think this is a symptom of perhaps elevated pressure in our garden system. We didn't actually see a pressure regulator over there at the standpipe where the backflow prevention device was, and we saw that our pressure in line was just below 100 psi. It was in the 90 plus range, which is pretty high for a system. Most drip systems operate down at 20, 30, 40 psi. Those MP rotators ideally should operate at 40 psi to be right on spec. So I would recommend for this garden that we consider putting a pressure regulator in that would step down the pressure in the system. That would take a lot of pressure off of these lateral valves so that they wouldn't tend to fail like this one has, probably due to the pressure behind it. And every time it shuts down, you hear that? That's not good. That's excessive pressure on the lateral valve. So it's leaking, and I think we could probably do something about that by reducing. We'll probably have to repair this valve, but we could probably solve a lot of these issues by stepping the pressure down in the main line. The other thing is, if we wire our master valve to the clock, which the master valve doesn't seem to be connected to the irrigation controller. If our master valve was in fact wired, the master valve would be closed right now, and this valve would not have the ability to leak because the system would be shut off further upstream. So that's the utility of a master valve, is that the master valve is closed unless the clock is operating any other valve, any other lateral on the whole system. So in this circumstance, when the clock is off and it's not operating any valves, that master valve would be closed, and this lateral valve would not be under pressure like it is right now. So we wouldn't be losing that water to a slow leak, which isn't enough to operate the irrigation system out in the field, but water's leaking through into the system, so it's drooling out of the irrigation system somewhere along the way. It's just not enough flow to actually operate the system, but the valve is not closed. The other thing we should look at here is, because this is a drip system, this is a filter regulator that is put in line downstream of the valve. This is stepping the pressure in the lateral irrigation line down from the pressure behind the valve. So this is reducing the flow and pressure into the system itself. It's also a filter that allows the, this is a Y filter, which is filtering any particulates out of the mainline water supply. There aren't a lot of particulates that come through, but occasionally little bits and pieces of sand or whatever can come through, and those can jeopardize drip irrigation emitters downline. So typically your drip systems have a filter to remove any particulates from the system. This particular unit combines both pressure regulation and filtration in the same little cartridge. I'm not going to open this because the valve is actually leaking and there's water coming through. If I was to unscrew this cap, we would see water come out of there, and I'm not going to do that because the valve is leaking. We need to actually repair this valve before we do further work with the system. So The fact that this valve is leaking when the clock isn't trying to run the valve, there's a hissing of water going through the valve. We're going to go ahead and use this isolation valve here to turn off water to the valve that's leaking. So there, we've isolated the leaking valve. We don't hear the hissing anymore. That should be fully 90 degrees to the pipe. And again, you can see here's the white wire, the white common wire connected to the solenoid, and the purple lead connected to the solenoid, and here's our solenoid here. So we might just do, as long as we're here, I can see from the twisting of the solenoid wires that this has been done in the past. But with the isolation valve closed, now this is not under pressure. So I'm going to go ahead and take the solenoid and unscrew the solenoid. You see how the wires are untwisting. Someone has done this before. Let's take the solenoid off. You want to be very careful, as that little spring is there to push the plunger downward. When it's no longer energized, there's the plunger, there's our steel plunger. There's the little stopper that sits on that little nipple there. That's our little pilot chamber. This plunger will be pushed down by the spring when the solenoid is not energized. That little spring will push the plunger down onto that little nozzle there and shut that off. I don't see any indication of some bit of debris in the chamber there. Sometimes a little bit of debris can get into the valve, into that pilot chamber, and stop the stopper from seating properly, and that can cause the mechanism to leak. I don't see anything obvious there, but we've unscrewed the solenoid, and there's its steel plunger, and there's our little pilot nipple inside. You can see, I don't think you'll be able to see, but because it's down in the chamber here, but when I raise that lever, there's a little bit that raises inside the chamber, which would lift this plunger off of that nipple and allow the pressure to flow through there. The fact that this is still spitting tells me that perhaps our ball valve isn't completely sealed, or this is just back pressure coming back through the system, but it seems to be fairly consistent. I'm suspicious that maybe this ball valve isn't completely shutting the flow off, and sometimes that can happen too. The ball valve can get a little obstruction that doesn't allow it to shut completely off. But we'll go ahead and put this solenoid back on there. It's important to keep the little plunger in place, get it down into the chamber, and then very carefully, delicately, with the solenoid fully upright, I want to find those threads carefully on the valve base and thread the solenoid back on. There we go. That's why those wires were kind of twisted before, is that someone has done the same thing in the past. Okay. So that's nice and snug, but don't over tighten it. Just nice hand tightness. Now let's see, we'll open our valve slowly. And still leaking. So, doesn't seem to be an issue in the solenoid chamber. We just cleared that out. Our next guess, 9 times out of 10, it will be your solenoid. That's the most common issue, is right in that solenoid chamber. And sometimes just taking that apart and putting it back together will solve the issue. My suspicion is there's an issue with the stopper and the diaphragm inside the valve. So the next step would be to open the valve and look at the diaphragm and the stopper on the inside of the valve chamber itself. So let's go ahead and shut this off. There we go. And then we'll need some tools we'll need a nut driver to remove those bolts to open the top of the valve. Okay, so here we are now. We have the nut driver that's needed to open this, open the bolts on this valve here. So we're going to be taking those off. This is a 7/16 nut driver. This is standard size for the bolts that are on valves. 7/16, you can see it says there. So that is the size you would need for standard bolts on these Weathermatic irrigation valves. So we'll go ahead and take this off. We've got the isolation valve shut, so our water pressure's off to our valve. We're going to go ahead and undo these a little bit just to get them loose. And kind of better to not do it all at once on one side. Once you've got them loosened up a little bit, you can kind of rotate around. You can see water starting to ooze out of the valve. So we're going to be taking pressure off the diaphragm and the seal. Taking off this bonnet. Okay, there we go. We may as well take these nuts out, bolts rather, and we'll put these in the chamber of our valve box lid as for safekeeping. Okay, so we're going to take off the top of the valve, and there's our spring which pushes down on the diaphragm and the stopper. Here is the stopper mechanism, and you can see the seat down in the middle here. This round ring in the center is where the water comes up. That's the pressurized side of the valve, pushing water up. The stopper seats right in that center ring there and stoppers the water closed. And it's when this diaphragm pops up and raises that stopper off of the chamber, that's when the valve is open and flowing. We can notice from looking at the stopper itself, this brass copper unit here, you can see all this corrosion here around the edge, and that is very suspicious. That is likely what's causing the valve not to seat properly, all that corrosion there around the edge. So since we checked the solenoid and the solenoid seemed to be fine, we didn't find any obstructions in the solenoid chamber or inside that little pilot chamber in the solenoid. I would suspect that this is what's preventing the valve from seating cleanly into this seat here, that the stopper is not stoppering closed perfectly well. So what we'd want to do is replace this stopper, or we could try sanding this stopper down a little, kind of clean it off and polish off some of that corrosion. But I think the easier thing to do, you could do that in a pinch. Really, probably the better thing to do, the more sure thing to do would be to simply replace the stopper. And we have with us a replacement diaphragm with the stopper already attached to it. The stopper is a separate piece that you could take off that screw and remove the brass to expose the, to replace the stopper itself and leave the old diaphragm in place. But the diaphragms are prone to problems too, so oftentimes if you're going to replace the stopper, you may as well replace this entire piece, which can be purchased separately from the rest of the valve part. So we're going to try putting that in, and we put it in here. You can see there's a ridge for the edge of the diaphragm to sit in. That becomes the seal that seals the valve, so it's important to get that settled in just down nicely into its little receptacle. So there's the stopper seated as it would be, and I ran my finger around the inner part of the valve base to be sure that there wasn't any obstructions or any kind of things that would be corroding or impeding the inside of the valve below the stopper. And the new stopper is nice and clean. So now what we're going to do is put this valve back on, and we want to be sure that the bonnet here is pretty clean. We don't want anything to interfere with the way the stopper will, with the way the seal will form. This ridge is what seals against the rubber outer ring of the diaphragm. So we want to be sure that everything's clean. And we're going to take this, and I'm going to take this opportunity to untwist the solenoid wires, just as a matter of clean presentation. Just untwist those wires so they're back as they should be. You might notice that this valve is missing the cross piece on the top. This is how we would determine how wide the valve can open when it does open. We can restrict the flow through the valve a little bit by tightening this down. Typically this will mostly be in a full open position. You might have a circumstance where you would dial this down and reduce the flow that can go through the valve when the valve is open, but that would be this control, which is usually a cross piece on the top of the valve. It's missing here, but that shouldn't really affect the functionality of the valve so much, so we're just going to leave that as it is. You'll notice on this little pilot chamber there is a little O-ring down around the base of that. That's very important to keep in place. That's what seals into this little chamber. So you want to be sure that that O-ring is in place. And as we sit this down into the chamber, we want to get that little nozzle down into the pilot chamber just so. And it'll go right back into place firmly, and there we have that. So now we'll put our bolts back. Just get them started by finger tightness. Whoops. Just push the riser down. I think that will pop up when the valve comes on. That was unexpected. I didn't mean to push that down. If the cross piece were on there, that would not have happened. But I was trying to sit this bonnet down on the valve base, and we'll hope that that pops up. So now back to our 7/16 socket driver. Tighten those down lightly to begin with, and it's best to crisscross back and forth across the valve as you tighten, so that you're gradually increasing the pressure around the whole perimeter of the valve. You can start giving a little twist. Again, you don't want to over tighten these bolts. Very important to make them snug, but not over tighten. If you over tighten these, for example, if you use a socket set with a leverage, with good leverage, and you can really torque those on, you can break the bottom of the valve base that those bolts are bolting down into. You can pull the nut out of the plastic base, as the plastic will fail if you over tighten these bolts. So don't over tighten them, make them snug. Now let's see if if our valve stem will pop back up when we pressurize the valve. Not sure. Yes, it popped up. And the valve seems to be seems to be holding. I don't hear any hissing. Our valve stem popped up nicely. And let's give it a little manual test to see how it does. There, it turns on the system. You can hear the sprinklers all spraying beautifully. The valve's flowing. Let's turn it off. And it shuts down nicely. So that was the issue. I believe it was this corrosion on the stopper edge that was just not allowing the stopper to seat perfectly onto its base. That right there, you can see quite a bit of material sloughing off of the valve. Some of that corrosion can be just simply removed, and that might be a thing to do if you're in a pinch. Putting new components inside, new pieces inside, is a good way of just sort of giving the valve a new life. So I recommend replacing it, but you know, there could be an argument made for just polishing this and reusing the same piece. So now that our valve is working properly, we may as well check the filter here. Because this is essentially a microspray or a drip system, drip microspray system, it does have this filter and pressure regulator unit that's attached to the system downstream from the valve. You can tell which is the downstream side because the solenoid sits above the downstream side of the valve. So if you're ever confused about which way the flow is, there is a little flow arrow on the valve that should show you which direction water's flowing through the valve. But just know that the solenoid is at the downstream side of the valve, so if you're ever confused, that's your downstream side of the valve. So the filter and regulator is downstream of our lateral valve, and we're going to go ahead and take this Y filter apart so you can see how it's constructed on the inside and how it functions as a filter. This is the filter medium, and the chamber is such that the incoming water flows up through the center of the mesh, perfuses through the mesh, and then out along the outer sleeve. So any impurities in the water would tend to be collected on the inside of the filter. So because those are inside the filter, there is this plug on the end, just a cap on the end, that if you wanted to clear that filter out, you would just take this cap off and blast water through it, and would blast the inside of the filter clean. So you can clean the filter without having to remove it from the setup by doing that. So in fact, we can just show you how that works. You put your filter back in place and close it back down. So we're going to put the Y filter housing back on and tighten that down. This time we'll leave this open. We'll leave this portal open. Now this is going to blow out full force with 90 psi, 90 plus psi behind it through a 1-inch valve. So what I'm going to do is turn this down a little bit just to restrict that flow somewhat. There you see, blows out the inside chamber of that little filter screen inside. So that would be a way to clean out the valve without having to remove the valve bodies, just to take the cap off the end and blow out the Y valve. It's called a Y filter, not a Y valve, it's called a Y filter because that filter is designed for you to be able to just clear the filter chamber by removing the cap on the end.